So I'll be doing number 12, and it says that a coin with a diameter of 2.4 centimeters is dropped from a ledge and onto a horizontal surface, and it starts out at an initial angular velocity of 18 radians per second and rolls in a straight line without slipping. So you can think of a flat surface and it lands on the edge and it continues rolling on the edge without falling on a flat surface. And then as it's rolling, the rotation slows to an angular acceleration of 1.9 radians per second squared, and it's asking how far the coin rolls. So then you write down the givens. So it tells you that the initial angular velocity is uh 18 radians per second, and the acceleration is negative 1.90 radians per second squared because it's slowing down. And then the radius or the diameter is the radius is 1.20 centimeters and the diameter is 2.4. It doesn't really matter, you can convert this either way. And it asks you for change in theta, and then it slows to a stop, so then you know that the final would be 0 radians per second. And then you set up the equation, so you do WF equals WI plus AT, and then you get the time is 9.47 seconds. And then after that, you get change in theta equals, or change in radians equals W initial times the time plus 1/2 angular acceleration times squared, and then you get this. And then you want to find the change in displacement now because it's not necessarily asking for radians, it wants it in centimeters. So then since you know the radians, there's 2 pi radians in 1 revolution. You can think of the revolution as the time it takes to go from one point of the circle to the starting point. So that would be the diameter. So then diameter would be pi d, and d would be the diameter, and then you would get 102.3 centimeters as your final answer.